So in part 2 of our moon video series, we're going to take a look at eclipses. You should have already watched part 1, the moon phases video, because that will be some good groundwork before we move into the eclipses. Now once you have an understanding of the moon phases, the eclipses are easy to understand. So there's two types of eclipses. There are lunar eclipses and solar eclipses. And we're going to start out with the lunar eclipses. So a lunar eclipse occurs when the shadow of the Earth, which is displayed right here, blocks the sun's light shining on the moon. So, as you know, the moon has a cycle around the Earth, and occasionally the moon will pass behind the Earth. So when the sun is positioned, and the Earth is positioned in between the sun and the moon, we call that a lunar eclipse. Now, you should be able to notice what phase the moon is in right now. And this is actually, if you remember, the way we did this is we look at how it appears from Earth. So we draw a line from Earth to the moon. You should notice that the moon is in full moon phase. So the very first question you should be asking yourself is, why don't we have eclipses all the time? Why do we ever even see a full moon if when the moon passes behind the Earth, it's called an eclipse? Because this is the position of a full moon. So how is it possible then that we don't have eclipses at all times? The answer being is that the moon's orbit is actually tilted 5 degrees around the Earth, meaning that it doesn't move around in a flat horizontal plane around the Earth. It actually moves upwards occasionally, then coming back down, and it moves to a lower point. It's on an angle to the Earth, the orbit of the moon. It's on this angle. So many times, like, we get the full moon when it's up at the top, and it's not in between, and the Earth is not in between the sun and the moon. So we see it from Earth. We can still look up and see the full moon, and the moon is not blocked. However, occasionally the tilt, the way the timing occurs is that the moon will then fall behind the Earth and fall into its shadow. And this happens a few times throughout the year. And when it happens on a full moon is when we have eclipse. So most times this doesn't happen. Most of the time we have a moon up in the air during the full moon phase and we see full light. But occasionally if the full moon occurs when it's behind the Earth, then we do get the lunar eclipse. And lunar eclipses are fairly common. We have them a few times throughout the year. But we have about 12 full moons throughout the year, and most of the time we do see the full moon. It's not an eclipse, but eclipses are not an uncommon occurrence. So this video right here shows that the orbit of the moon is a little bit different. There's this plane between the sun, Earth, and moon, and the moon is most of the time either above or below the plane, but when it does happen to experience a full moon along this plane is when we get the eclipse. And again, the moon's orbit shifts slightly throughout the year, and this causes these planar alignments to occur at different times. So the Earth casts, and everything actually has two parts of a shadow. There's actually an inner darker part of a shadow, and there's an outer lighter part of a shadow. The inner darker part is known as the umbra, and the outer lighter part is known as the penumbra. Clearly the umbra is much smaller, but the penumbra and umbra are both parts of the shadow. So the shadow that you would see, maybe that's cast by your body on a sunny day, you'd see both the penumbra and the umbra. Next time I encourage you to go outside on a sunny day, notice that you should see an inner darker part of the shadow and a lighter faded outer part of the shadow. So umbra is the inner part, penumbra is the outer part. Two vocab words that would be important to understand. So a lunar eclipse lasts for a few hours. Again, eclipses occur when the moon passes through either the umbra or penumbra of the Earth. So the Earth casts a shadow with the penumbra and the umbra, and if the moon moves around and happens to have a full moon when it's in the umbra or penumbra in that plane, we get two types of lunar eclipses. A penumbral eclipse only appears as a light shadow. So if it just passes into the penumbra, and then you almost wouldn't even notice it. Penumbral eclipses are very common. You've likely seen a penumbral eclipse but not realized it. This is a regular full moon. This is a penumbral eclipse moon. There's hardly a difference. Umbral eclipses happen less frequently, but they're much more obvious. This is something that's very likely for you to have seen before. If you've ever seen a reddish-colored moon, that is due to the moon passing through the umbra of the Earth. Now, we still get to see the full moon. It doesn't disappear, but it now has this reddish color, and that's the umbral part. So again, if the moon passes into the umbra, we get that reddish color, and if the moon passes into the penumbra, we get just that light shadow.
So using this model, look at the position of the full moon above the Earth. Recall that due to the fact that the moon's rotation is not fully on the same plane as the Earth, it usually passes above the Earth when it moves behind it. So most times we look at the full moon, we see it no eclipse. Usually we just see the regular full moon because of the fact that it's either above or below the Earth. So now look at the difference in this model. This time, it's still a full moon, but the full moon is now passing behind the Earth's shadow. The Earth is actually blocking light from the sun, so it's not reaching the moon. In this situation, we have either a penumbral or umbral lunar eclipse.
Part 2 of this video, solar eclipses. Solar eclipses are more or less the opposite of lunar eclipses. A solar eclipse occurs now when the sun is blocked out. So solar, sun, lunar, moon. A solar eclipse occurs when the sun is blocked out by the moon during the day. So, based on this diagram, you should be able to tell what phase the moon has to be in for a solar eclipse to occur, because this is the only position a solar eclipse will occur in. If you, again, draw your line from Earth to the moon, right away you should notice that this is a new moon. New moon is the only phase in which a solar eclipse will occur. The next thing I want you to notice, based on this picture, is notice how small the moon is compared to the sun. You may be asking yourself, how is it possible that the sun can be blocked out entirely by the moon when the moon is so tiny and the sun is so large? The scale is unbelievable. Thousands of moons could fit inside the sun. So how is it possible that just one moon could fit block out the entire sun? Now, if you were listening during my last video, you recall that I told you it was the distance of the moon to the Earth that makes this possible. Do me a favor watching this video. Take your thumb and stick it over the nearest light and put it really close to your face. So take your thumb right in front of one of your eyes and then block out the light. Now, your thumb is much smaller than whatever light you just tried to block out, but if you had the thumb close enough to your one eye, you blocked it out entirely. And that's because your thumb was much closer to your eye. It was able to block out all the light reaching your eye. Same principle with the sun and the moon. The moon is very close to the Earth, so even though the sun is much larger, just like your thumb blocks out an entire light, the moon can block out the entire sun.
So let's refer to our model again. So as you can see, the position of the moon is above the Earth. It's not in between the Earth and the sun. So if that position of the moon were to go in between the Earth and the sun, only then would we have an eclipse. Ordinarily, when we have a new moon, the moon is still in between the Earth and the sun, but it's above the plane of the Earth and the sun, so it doesn't block the light from the sun. Alternatively, if we have a new moon in which the moon does pass in between the Earth and the sun and it does land on that plane, we will get a solar eclipse because the moon is now blocking the light from the sun, preventing it from reaching the Earth.
So solar eclipses occur only during a new moon, when the moon moves between the Earth and the sun. They're only visible to a very small area for only a few minutes. If you recall, lunar eclipses occur over a few hours, and a larger area of people can see them. An entire hemisphere can see them. But a solar eclipse, only a small portion of the Earth can see them, and they only happen for a very few minutes. There's different types of solar eclipses, and before you understand the different types of solar eclipses, you need to understand the position of the moon around the Earth. The moon sometimes passes very close to the Earth, called its perigee, and the moon passes very far from the Earth, called its apogee. The orbit of the Earth is not even. If you notice, it's actually uneven around the Earth. At some points it moves farther away, at some points it moves closer. Perigee, it's closer, apogee, it's farther. So if a solar eclipse occurs when the moon is at its closest point, or the perigee, it's called a total eclipse. Because remember, now the moon is closer, meaning it appears larger to us, and it can block out the sun entirely. So we call it a total eclipse, because the moon is able to totally block out the sun because it's closer during its perigee. An annular eclipse also occurs when it's not fully at its perigee, but it's close enough to block out most of the sun, and we call it an annular eclipse. Now it's not blocking it out entirely, giving us that white background, but it blocks out most of it, giving just a yellow ring. That's an annular eclipse. Again, it's not at the perfect perigee like the total eclipse, but it is close. Then the last type of solar eclipse is the partial eclipse. This occurs when a solar eclipse happens during the moon's apogee, when it's farther away. So now the moon isn't nearly big enough to block out the entire sun, and it's only partially blocking it out. They're still considered an eclipse, but it's called a partial eclipse because the sun is only partially blocked out by the moon.